Hello, let's start with our today's DSA journey with this amazing visualizer by dsa.chaicode.com. Use this link to get a 7-day free trial. So now let's move to our today's question, and today is the last question of stack, which is evaluate reverse polish notation. Okay, so evaluate an arithmetic expression in reverse polish, which is postfix notation. Valid operators are plus, minus, multiplication and division. Division truncate towards 0. Return the expression value evaluates to. Okay, so this is our question, but first understand this reverse polish. Okay, so according to this, reverse polish is postfix. Okay, also it is postfix, and postfix means simple. So if we given two numbers a plus b, okay, we can easily calculate this a plus b. Okay, just suppose a and b both are two integers. This is called infix. Okay, but now what about postfix? So a, b plus. So this equation simply means a plus b. This is actually into a human readable format, but our computer understand this very well. Okay, because we are using stack in computers. So this is called postfix. So this is called, okay, so this is called postfix. So what is this? So what this means, a plus b, okay, is nothing else. So suppose a b plus c multiplication, it simply boils down to our human readable infix formation, which is nothing but a plus b, okay, into c. So take this a b plus c. So a b c multiplication. Okay. So a b plus, it will give us an answer. Let's suppose this will give us a plus b. So a plus b is nothing but, let's suppose a plus b is equal to d. Let's assume a plus b is d. So it become dc star, and when you convert it, it will become simply as d star C. Okay, and what is D? D is nothing but A plus B, or this one, anything you want. So it will become A plus B into C. So this is how we boil down postfix. And now we are given this one, and we have to give the actual answer. Okay, so let's just, okay. Let's just take this. We have to give the answer. We are using a stack. Okay, do you really see the situation here? First we calculate a b plus and store it as d, the answer. Then you multiply this d here. Simple. First we calculate the value like this, and then store it here like this, and then we just multiply it with c. So we do the same thing here using stack. How? Let's take a stack. First we take a stack. What is the first element? 2. Put it here. What is the second one? 1. Put it here. Now we got an operator, which is a plus or minus plus. Okay. So in the case when we got a operator, we pop this one, we pop this 2 and perform 2 plus 1. Simple. And we get 3. Now in this step, our same stack is take 3, and again we got and we insert this 3. Now the multiplication we encounter. So simple as that. Pop this 3 and 3 multiplication 3. As simple as that. And we get our answer as 9, and at the end push the 9 towards to the stack, and the answer is always lie in the top of the stack. Okay, let's visualize it actually. Reverse polish postfix notation puts each operator after two operands. So actually, see this two, this one, these two are operand, and this plus or this multiplication is the operator. Okay, so let me just, okay, so no bracket are needed. The classic tool is an operand stack. Scan left to right, push every number, and when an operator pops, two operands act on it, combine them and push the result back. Okay, so simply scan 2, 2 is a number, put it. 1, 1 is a number, put it. Now we got an operand. Plus is an operand. Pop 2 operand. Plus is an operator. So pop 2 operands, which is 1 and 2 here. And the simply just left plus right. Okay. It's nothing but. And push the value to into the stack also, which is 3. Now again push the value. Then we got another operand. So calculate it as 9, 3 into 3 as 9, and push back to the stack, and at the end return the top of the stack. Now write the pseudocode for this. So first we are given a function, and actually we are given an array or vector. Let's suppose A as array or vector, and take a stack st, which is nothing but at the starting an empty stack, so now traverse it from the to the end start to the end. If the array of that index is a number, then simply push it push the number into the stack. Okay, and otherwise if it's not a number, it's simply a operand. We can take like second number, or we can take left and right also, because 2 is our leftmost index and 1 is our right operand. So with this operator plus, 2 is the left operand and 1 is the right operand. So take is at left, and which one is the top? At the top one is the right and bottom one is the left. Okay, so first take the left, no, first take the right, which is nothing but st dot top, and just pop this. Okay, and now go to the left is nothing but st dot top, and pop the element. Performed. Now perform it like st dot push. We have to push, and what we have to push? The right, or the left, the operand, we take it as op here, and the right one. As simple as that. First we take the right index, right operand, then the left, then we just put this using operator, and at the end return st dot top, because answer at the top. Now evaluate it and check it. Okay, which is not standard way to denote. Okay, this one should become a, I think it is okay. Or rather this one. Let's see it works or not. Should work. Because it is simple. If ensure that number is clearly defined, it is okay. Because we are checking every number and then we are taking this and then just push it. So it should okay. And I think we took A here. Maybe the algorithm doesn't work because of A, but if we took add A, it should work. Let's start it. Because of A, the model cannot identify what is A actually here. So by choosing ARR, we specified that this is an array or a vector. So our whole pseudo code. Okay. Now let's go to the question and let's solve it. Okay. Uh, First take a stack, and the stack should store integer. Uh, Now we are given a vector of string. Okay, so let's take it for string. Let's take it like this. Token. We just took every token from these tokens. Okay, and we choose every token from this token. And now check if it is a number. Check. We can actually do it in a very interesting way because only we get this 4 as operator. Okay, so the operand may be integer, other expression division truncate, so there will be not be any division by 0. Okay, uh, the array will indication. Okay, so there are only these 4 operators, so we got this token. Interestingly, we got this token, so we take every index, every value. Now if we check if this is not equal to plus, or yes, this token is not equal to plus or minus or multiplication or division. Okay, so if the token is not equal to with these operators, so it simply means it is a operand or a number. Okay, so st dot push, but we cannot directly push it because it is a string. We take everything as a string, like this 2 1 plus 3 multiplication, everything is a string. So we have to convert it, to a integer, and we can convert it using stoi of token. So we can check is the value are actually these 4 operators or not. If none of these 4 operator, then it simply means that it is an integer. So we just store the integer by converting the string into an integer and push it into the stack. Okay, we just push it into a stack else, and this is simply means we reach a operand which is plus, minus, multiplication or division. Okay, so now we have to calculate this. We calculate this like right and left. So first one is the right, so take the right. Int right is equal to st dot top and remove the top element, so st dot pop. And now take the left element, left, which is nothing but also in the top, so we take top two elements and st dot pop, so we just pop the element, so we left and right we pop. Now we have to check, we can easily make a if else condition here because we only get these four operators. Okay, so we can easily do a if else statement. If the token is equal to plus, then simply st dot push left plus right. We do this by like four if statement, although we can use a switch case here, but it is much more easier, much easier this one. Just put four if statement with simply like, is it plus, minus, multiplication or division. Just push everything into the stack using this, and at the end just return st dot top, because at the top we have our actual answer. So let's run it and check it. Okay, invalid argument. Where is the invalid argument? Okay, where is the problem? Just take everything as string, just push it using converting into integer, string to integer, then take the top value and just check it here, left plus right, left minus left. mm, it should work, but I am missing something. Let me debug it, actually give me time. The condition here is wrong, we have to provide and here. Why? Because if any time we reach, because we don't want a plus, not a minus, not a multiplication, not a division, so mistakenly there was an or. This should be and, that should be and, not an or, because we don't want anything and we just done it. So this is our last question of stack, where we take evaluate reverse polish notation. Okay, very easy question. Mention, remember that only ands and are there, and we have to take and because we don't want a plus, not a minus, not a multiplication, not a division. Okay, then it is a number, so we need this. So this is our question, and the time complexity is simple. We just loop through the array one time, so the time complexity will become big of n. N is the size of the first array of string, and space complexity we are using a stack, and we can easily say big of n, although there will be only one element at the top, but we can say that as big of 1. Here also it is given big of n also, because we are using a stack, simple, and stack can store every element, so that if everything is a number, then it stored everything. Okay, so this is our question, although that will not happen. So this is our question, our time complexity is big of n, our space is big of n. Okay, so here we just complete our stack. That is it. Go use this platform, use this link to get a 7-day free trial. Thank you very much. Use this platform at dsa.chaicode.com. Thank you.